Alrighty, so if we're looking ahead this week, short week because today's first day of the week. So we've got 5.9 today, which we're going to be choosing a strategy for solving these systems. Okay. Tomorrow we'll enhance that, and then on Thursday we'll tie it all together with this week, Friday being a work day, catch-up day. Finally, get your quiz corrections done, kind of a day, all that fun stuff. Okay. So I got some notes today. I do have your quizzes from last week to hand back to you, and I'll do that at the end of class. And then some homework today. Okay. All right. So we are in your note packet. We are on page 27 of your note packet. There appears to be 5-ish. Well, that whole page. So there's 6 problems to do on that packet. So number 1, we're determining what's the solution. Number 2, looks like we got to figure out what the solution is using algebra. Number 3, we can get it off of the graph. Number 4, what's the definition of a function? We'll talk about that. And then number 5 and 6 is determining if it's a function. Playing the game, is it a function? Is it not a function? Conjunction, junction. What is your function? Okay. Give you a couple minutes to complete page 27. I got -1, 1 for the solution for both of those. Yes? Because it's the same point that shows up in both of them. Yeah. All right. I get -11, 46 for that one. 55 minus 9 is 46. Yep. Agree with me on that? I get 5, 5 comma -4 for that one, where the lines intersect. Yes? Okay. What makes a function a function? You're thinking of a system of equations. Yep, you're thinking of a system. Would be 2 or more lines. Yep. For every one input, there's exactly one output. For each input, there's only one output. Okay? When we have a graph, how can we determine if it's a function or not? Take it back to, I think it was Unit 1 or Unit 2. We talked about it first semester. What? What kind of line test? There it was. I needed that V word. A vertical line test. Yep. So we take a vertical line test. So we take a vertical line. and we slide it across. Now, what can we use for a vertical line? Pretty much anything, right? You can use your hand, the side of your hand, you can slide it across. You can put your pencil down on your paper, you could slide it across. You could take your piece of paper, you can take a piece of paper and roll it over and slide it across. Okay? You can take another piece of paper, as long as that line is vertical, straight up and down, while you're going across, and that your alleged function can only touch that vertical line once as you're going across. So in number 5, function, not a function. So far it's still a function. Function all the way across, yes? Okay. Number 6, function, not a function. Not a function because it touches the line twice. Okay. So this is a function. This is not a function because it touches twice. Okay. Questions on any of that? No? All right. Let's dive into it. Actually, here, let me go back and then let's go like this. So last week, Thursday, the last time we met, we talked a little bit about elimination. Okay? Okay? So I wanted to refresh your memory with the steps that we had for elimination. Because I think you'll find it'll be your go-to. Okay? Step number 1 that we had from last week, Thursday, was we need to get the same number in front of the same variable. One's going to be positive, one's going to be negative. We do that, sometimes that's already set up for us. We call those the jackpots, where it's already done for us. If it's not, then we do that by multiplying one or both equations by a number. And we have to multiply the whole thing, all 3 parts, because there's going to be an x part, a y part, and a numbers part. All 3 of those parts get multiplied by that same number to make that happen. Okay? Then we said step number 2, we add the new equations. We straight up add them. Okay? X plus X, Y plus Y, number plus number. And by doing that, we should get a 1 variable outcome. So after you add them together, you should have a new equation with just 1 variable. It should be something x equals a number or something y equals a number. Okay? Or whatever variables you're using at that time. Then in step number 3, we solve that. So now we've got what 1/2 of our answer is. In step 4, we plug what we got in number 3 into an original equation to get other variable. Kind of like what you did in substitution. Okay. And then step number 5 is kind of a 2-for-1 step. We put it in point form and we check our work. We check our answer. The most important part of that one is you check it. Okay? So we'll refer back to that because we're going to do some more elimination today later on. Okay? But I wanted to go over those one more time. Okay? So today we're going to talk about choosing a strategy because sometimes substitution is the way to go. Sometimes elimination is the way to go. You'll find that graphing is probably never going to be the way to go. Okay? We'll give you graphs on tests and quizzes, but you won't necessarily have to use them. Okay? Because there'll be a problem on next week, Tuesday's quiz. You have a test in a week, by the way. No, yes, test in a week. Okay? So on next week, Tuesday's test, you'll find that there's a problem. And I have room to work, and I got a graph. Because graphing is your third option, and some people love graphing. Okay? Erica works in a soda bottling factory. As the bottles pass on her conveyor, she puts caps on them. Unfortunately, Erica breaks a bottle before she can cap it, sometimes. She gets paid 4 cents for each bottle she successfully caps, but her boss deducts 2 cents from her pay for each bottle that she breaks. Erica's having a bad morning. 15 bottles have come her way, but she has been breaking some and has only earned 6 cents so far today. How many bottles has Erica capped, and how many has she broken? Okay? So we need to write a system of equations representing this scenario. Okay? So, what do we want to use as our variables?
X and Y.
X and Y? Okay, what's X going to be? What did you say? Bottles capped? And what's Y going to be then? Bottles broken. Yeah. Bottles capped, bottles broken. Okay. We have 2 variables, so I need 2 equations now. Anybody got one of the equations? What do you got?
X plus Y equals 15.
Because there's 15 total bottles that came by?
Yes.
I would concur with X plus Y equals 15 is the 15 bottles have come her way. That was this part right here. That's going to be that one right there. Okay? Now I need a second equation.
4x minus 2y equals 6.
Equals 6. Because she's earned 6 cents so far today, and she gets paid 4 cents for each bottle she caps, but deducts 2 cents for each bottle she breaks. Agree with that one? Okay? All right? So now it's asking us to solve that system of equations using 2 different methods, substitution and elimination. Okay? So substitution, we'll do substitution first. For substitution, I need to solve one of our equations for one of our variables. Which equation, top or bottom, do you want to solve for? And which variable, x or y, do you want to solve for?
Top and one.
Top for y, okay? How would I go about solving the top equation, x plus y equals 15 for y? Subtract x from both sides. That gives me y equals 15 minus x. Okay? Now that I've solved one of the equations for one of the variables, now I'm going to take that equation and I'm going to plug it into the other one. So I've got 4x minus 2, but instead of y, I'm going to write 15 minus x, and that's going to equal 6. Distribute and distribute. So that's going to give me 4x minus 30 plus 2x equals 6. Four x plus 2x is 6x. Minus 30 equals 6. How would we solve that? Add 30 to both sides. Oh, I should have changed my color here. So that gives me 6x equals 36. Divide by 6. How much? How much? 6. Okay? If she's capped 6 bottles, then I can plug that back into x plus y equals 15. So now I can say that that is 6 plus y is 15. So I can subtract 6. How many bottles has she broken? She's capped 6 bottles. She's broken 9 bottles. I mean, she's had 15 bottles go by her, right? Okay, so that's satisfied my first equation. If she's capped 6 bottles, how much money has she made? At 4 cents a bottle. She's made 24 cents, right? If she's broken 9 bottles, that's 18 cents that she's had deducted, right? What's 24 minus 18? 6. So she's only made 6 cents so far. Okay? So that works out. Okay? So that's substitution. Now, let's do, tap the brakes. Whoa. Hey now. There we go. Okay, so now let's solve this using elimination. Okay? So step number 1 from elimination was we need to get the same number in front of the same variable. So I need to pick a variable, x or y. Y, okay? If I'm picking y, then I'm going to take x plus y equals 15, and I'm going to multiply everything in it by 2. And that would give me 2x plus 2y equals 30. Do we agree with that? Then my second equation was 4x minus 2y equals 6. So I can add those two equations together. 2x plus 4x is 6x. 2y plus negative 2y is 0. That's the elimination. That's the one that made it go away. 30 plus 6. 36. How would I solve 6x equals 36? Divide both by 6, and that would give me x equals 6. 6 bottles capped. Good so far. Plug it back into x plus y equals 15, which is the same as right here in the middle. X plus y is 15, x is 6. Now instead of having a blue 6, we have a purple 6, but everything else is the same. So we get 6 capped bottles, 9 broken bottles. Okay. Now, what I would like you to do is, on the next page, there are 4 problems. I want you just at your table, not to solve them yet. Okay? I just want you to determine which method you would use on it. Okay? And why. Okay? Got it? So you're just picking which method, substitution or elimination, you would use to solve all 4 of those. Okay? I'll give you 4 minutes to discuss those 4 at your table. Go. Go round robin style. So the numbers that your tables are truly numbered. I can see what the numbers are. You might not know what it is, but it's 1, 2, 3, 4, 5, and then you guys are table 7 in the back. Just so you, okay? So we'll go fantasy football draft style. Okay? So we'll go 1, 2, 3, 4, 5, 7. Then we'll come back 7, 5, 4, 3, 2, 1 on the next one, and then 1, 2, 3, 4, 5, 7, and then 7, 5, 4, 3, 2, 1 coming back. Okay. So number A, letter A. What did you guys choose? Substitution. What did you guys choose? Elimination. What did you guys choose? Substitution 4. Substitution 5. Substitution 7. Substitution. Okay. All right. You guys were the only ones that chose elimination. Why did you choose elimination on that one? As is? Or do you have to do some stuff first? Okay. Okay. I would agree that you would have to do some stuff first for that one. Everybody else, somebody want to tell me why you chose substitution?
One of the variables is already solved.
Bingo. Exactly. Yeah. Yeah. It's set up for you already, right?
Yeah.
Yeah. Okay. I agree. Now, my question to you is this: were these guys wrong? No. They just would have to do a little extra work at the start to get it so that everything lines up, right? Okay. On all of these, it doesn't matter which one you choose. Okay? You're going to get the same answer. We just proved that on that last example. No matter how we solved it first with substitution, then we did elimination, we got the same answer. Okay? All right? B, table 7, what did you guys choose? Okay, 5. Elimination. 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 Okay, wait. So, again, not wrong, right? Okay. Which one would you solve for? Which Which variable, which equation? Yep, exactly. And then boom, it's up there, right? Okay. You guys that chose elimination, what do you got to do first?
Times everything by negative.
With either the top equation or the bottom equation, right?
No.
Doesn't matter which one, right? Okay. So you got to do it. So in both of those, you still have to do a little bit first, right? Okay. Letter C. You guys first. Elimination. 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 Wow, we all chose it. That's fine. Okay. What do we got to do in order to do it? Multiply the bottom equation by 2, and then it's all set up for us, right? Okay. Love it. D. Elimination. 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 Multiply what? Top equation by 3? Top by 3? Okay? What I want you to do now, and I'm going to give you a little time to do this, I want you to solve just C and D. Okay? However method you choose, solve just C and D using whichever method you choose. So we said we were going to multiply this one by 2, this bottom equation by 2. So then that's going to give us negative 6x plus 2y equals 76. And then that's going to give us 6x minus 2y equals negative 76. When we add them together, negative 6x plus 6x. 0, 2y minus 2y. 0, 0 plus 0 is 0. 76 plus negative 76. 0. Is that a true statement or is that a false statement? The true statement, so what's my answer? Infinite solutions. We said we were going to multiply the top equation here by 3. So that would give us 15x plus 9y equals negative 18. Bottom equation is 2x minus 9y equals positive 18. We add them together. That gets me 17x, y's go away, equals 0. How am I going to solve 17x equals 0? Divide by 17, so x is 0. Okay. Plug in top or plug in bottom? Bottom. Okay. So then that would be 2 times 0 minus 9y equals 18. Come on. Two times 0. So then this just becomes negative 9y equals 18. Divide by negative 9. And I get y here is negative 2. So my final answer then there would be the point 0, comma, negative 2. Scroll back up just a bit. Plug it in. 5 times 0 is 0. 3 times negative 2 is negative 6. 0 plus negative 6 is negative 6. And negative 6 is equal to negative 6. 2 times 0 is 0. Negative 9 times negative 2 is positive 18. 0 plus 18 is 18. And 18 is equal to 18. So it works out there. Oops. Why is it doing that, Kara? Checked it. Now I can box it. Questions on either one of those? These purple lines right here are different. 0 equals 0 means infinite solutions. 17x equals 0 means x is equal to 0. They're different. Okay? Homework this evening is in your homework packet. I also handed back any quizzes or tests or homeworks that I had. Okay?